Alright, this is the review for test 2. Question 1 says a professor wanted to find a linear model that relates the number of hours a student plays video games each week, which is H, to the cumulative grade point average G of the student. He obtains a random sample of 10 full-time students at his college and asks each student to disclose the number of hours spent playing video games. So here we have the hours and the GPA. Part A, explain why the number of hours spent playing video games is the independent variable and the cumulative grade point average is the dependent. Well, here we just basically want to use the number of hours spent playing to predict the grade point average. And the grade point average is basically, a number that is found by the grade in the class, and we know that that correlates to how much time a person spends in the class. So if they're spending more time on games, they're spending less time on studying, hence the GPA would be a little bit lower. So this would be C. The number of hours is being used to predict the cumulative grade point average. Now here we just get a scatter plot of the data, and to do that we go to our calculator here and just go to Stat and then Edit, and we type in the X values and then the Y values, and then we can go to Stat and then Calculate and then Linear Regression, which is option 4, to get the equation of the line. So here we just hit L1, comma L2, and then enter. And here we get the value of A. The slope is this number, and then the y-intercept is here. Now once you got the data entered in as well, you can get the graph of the data. So just make sure that you have stat plot, second stat, turned on. So this will be turned on or off here. Just make sure it's turned on. Okay, so here's our function that we get from the calculator. And then here's the meaning of the slope. So basically we look at this number here and we think for every hour, for every H value that we increase, the GPA is going to go down because of the negative slope by this amount here. So if the number of hours playing a video games in a week increases by 1 hour, the cumulative grade point average decreases by 0.1 on average. And then how many hours of video game play does a student play whose grade point average is 2.9? So basically we have our model and we plug in 2.9, which is the grade point average, and then we solve for the number of hours. So we solve this linear equation and we get 6.96, which is approximately 7. We're going to round to 1 decimal place, and you want to pay attention to that. Alright, question 2. I have a quadratic function. We want to graph it first. So to graph it, I find the vertex, which is x equals negative b over 2 times a. It's equal to 3, and then we just find the y value by evaluating the function at x equals 3. And we get minus 16. So 3 minus 16. So once we have the vertex, we can just plot that, and then we need to get one more point. We just need one more point using this tool here, and the easiest point to get is when x is 0. We get f of x or y is minus 7, and that's the point here. And then you can draw the graph through there. Now the domain, of course, is all real numbers. The range is starting from minus 16, including bracket, and going up to positive infinity. Decreasing, determine where the function is increasing and decreasing. So it's increasing from minus 16 to infinity, and it's decreasing from minus infinity to increasing. We always use x values here. So increasing from positive 3 to infinity, and decreasing from minus infinity up to x equals positive 3. And so those will use both the interval notation here. Okay, question 3. We have a farmer which has 1,500 meters of fencing and wants to enclose a rectangular plot that borders a river. So he's not going to use fence along the river. So he'll have two of these X lengths, and then he'll have the width, of course, will be 1,500 minus the two X's, and that will give him the length. So what's the largest area that can be enclosed? Well, the area is just the length times the width. So if we let the width be this and the length be x, then we've got x times the width, and we get a quadratic here. And basically the question boils down to finding the vertex of this quadratic. We do that by x equals negative b over 2 times a, and we see that x is 375. And so this is 375, this is 375. And so now we just evaluate the area function when x is 375, and we get 281, 250, which would go right here. Now question 4, we've got several functions, and we want to know which ones match this function here, or could match. Well, a couple of things we want to do here. First is just figure out the end behavior of this kind of function here. Now notice we've got a root at 0, we've got a root at 1, and a root at 2. So I wrote those down. And then it touches here, it touches here. So that means multiplicity is odd. Touch, touch. No, excuse me. Multiplicity of even. Whenever the graph touches, that's a multiplicity of even. So it must be even here, multiplicity of 2. Touches here, must be even here, multiplicity of 2. And then it crosses at x equals 2, which gives an odd multiplicity. And so that's going to be a multiplicity of 1. So we get power x to the 5th, which behaves like this. Now what we can do is look at each one. So this one definitely would not work, because at x equals 1 and x equals 2, we have an exponent of 1, which means they would cross there. Here we have multiplicity at 0 is even, multiplicity at 1 is even, so this one would work. And then at 2 it crosses, it's 1. So b, we can put b down. C would not work because multiplicity of 1, multiplicity of 1. D would not work because multiplicity of 2 at x equals 2 means it should touch at that point, and it doesn't, it crosses. And then here the multiplicities are the same. So the only one that works is B. So these are the kinds of things you want to pay attention to here. Okay, moving on to question 5. Find the real solutions, the following equation. So what you should do is use your calculator to find the first real root, and that's 2/5. And of course we do synthetic division here. Bring down list the coefficients, 5, minus 2, minus 35, and 14. And then we perform the process of synthetic division. Bring this 5 down, multiply, and then add. And so here we get our reduced polynomial. So this will be 5 times x squared plus 0 times x minus 35. And then we can solve for x by just adding 35, dividing by 5, taking the square root. So these are the 3 solutions to this equation. We do the same thing here, find the zeros. So type this into your calculator and find one of the real zeros, and one real zero I found was 2 from the calculator. So I can do synthetic division here, and I get the reduced polynomial. So 1 times x squared minus 6 times x and plus 13 equals 0. We want to factor this using the quadratic formula. So I did that here, factored. Negative b is the formula for quadratic. X equals negative b plus or minus the square root. B squared minus 4 times a times c. So we plug all that in and we do a bit of simplification. and we get two roots, x equals 3 plus 2i, and x equals 3 minus 2i. So we've got 2 is a 0, so x minus 2 is a factor. That's what we get here. And then x minus the 3 plus 2i, and then the other factor is x minus 3 minus 2i. And you want to put these in parentheses, and then we distribute the negative sign. Be sure MyMathLab wants you to distribute that negative, so you must distribute that negative sign. Number 7 is a rational function. We want to find the domain and range. So the domain here includes all real numbers except minus 1 right here. And the range is going to be minus infinity to infinity except, so y cannot be equal to 4. So the domain is x such that x cannot be equal to 1. And the range, be very careful here. You have to use x and you have to use y for the range. Y is not equal to 4. This will help you on the test review and the exam. Now the x-intercepts and the y-intercepts, well, there's only really one. X-intercept occurs at x equals 0, and then the y-intercept occurs also at y equals 0. Horizontal asymptote, if you look back up at the graph, occurs at y equals 4, and the vertical asymptote will be x equals minus 1. And there are no oblique asymptotes. And there won't be any with oblique asymptotes, so you don't have to worry about that. Okay? So the graph of the function is given. Use the horizontal line test, and since this horizontal line intersects at more than one point, it's not a one-to-one function. And then here, find the f inverse, so the inverse function of f given by f inverse. So here's how we do that. Basically, we just write the function down, and we write f of x is y, of course, and then we interchange x and y. So I did that in this step, and then basically we solve for y. So once we interchange x and y, now we just solve for y. So I just cross multiplied here, and then distribute the x to the y and the 8, and then solving for y means we collect all the y's on one side and all the other terms on the other. So once we get the y variables on one side, we can factor out the y and then just divide by this x minus 9 term. So this is the inverse function. Okay, I hope this video helps you, and at least do a couple of copies of the sample test before the actual exam. Oh, there's one other thing I wanted to mention. You might see a question like this on the test as well. So on the application of quadratics, you're either going to have this one or another one. And so here we have 3,600 yards of fencing to enclose a rectangular area. Now the only difference here is we don't have a river. So here we're going to have 2 W's and 2 L's. So the perimeter, which is 3,600, is equal to twice the width plus twice the length. And then we want to write the function, express the area in terms of W. So that's the reason I solved this equation here for L to express this equation in terms of W. Now once we get L in terms of W, then the area is just the length times the width. Well, the length is equal to this. So we plug this in for length and we get a quadratic. And again, this here is what we want for part A. And then to get part B, what would the width be for the largest area? We use negative b over 2 times a, and that gives us 900. And of course, once we got that, we can plug 900 in for w and get L. So that's what I did here, 900. And then to get the maximum area, we just multiply L times w. So 900 times 900 is 81 with 4 zeros, which gives us 810,000 for the max area. Okay, so this is the test review, and like I said, You've got the answers here, and now you have the solutions. So I recommend you do at least a couple of copies of this in my math lab, and then do all the homework. If you do that, you should definitely be successful. Okay, have a great day. See you next time.